Hello.
Hello. I hope you survived my dashboard is gone shock. And you're still muted. Still muted.
Yeah, I was getting the heart attack, but I survived. Oh man, that was exactly correct timing for that sort of surprises. That's definitely something I would like to see before giving a session that involves this dashboard. That was like, wow.
But yeah, it's a classic. Last week it wouldn't have been deleted, perhaps also not next week, but exactly on the day that we wanted to talk about it. So yeah.
Yeah, so it's technically, apparently this means that we are cleaning on Mondays, right? Apparently, but like, what's the pattern? Like, what triggers the things to be removed there?
I think it's just like everything that is not on a specific folder, and the testing playground is simply cleaned out once a month or so.
Right. Okay. Got it. Okay, that sounds like something. I definitely hope that this dashboard, the new one, won't be gone next week. Oh, Sarah, stop cloning yourself now.
Yeah, I don't know why. I quit and thought it would help, but I think it just has some crazy process. Oh, look, it's gone.
Yeah, okay. That's something that happens to me sometimes as well. It's just like duplicates the things and that's it.
So give me one more second. I'm going to, you already. Right now. Perfect. Now I made a little bit more advertising. I hope that our waiting room is not broke more so. Okay, no, should be good. I just made a posting in the front-end channel. Of course, you set up a new session and exactly the second time it's already on a huge bank holiday in the US. Sarah, thanks for joining anyhow. So a lot of people are out today, so I was not expecting too many, but this is really way less. So let's see. I think as it is just in that calendar and not the front-end calendar yet.
I edited to the front-end calendar right after that, after the first session. So it is in the front-end calendar.
Okay. Should we then simply get started and take a look that we have a good recording and share it afterwards with everyone who wants to watch it? Or should I start with some other things and let's see if someone else is joining, as you wish?
Whatever you prefer.
Okay, then simply let's get started. Tell us something about user timing metrics, please.
Right. User timing is something that I'm telling about for a bit over a year already, and finally we've got some traction and we've got some information. So this session is going to be it was quite spontaneous, so I don't have a lot of slides to show, so you will have to stare at my face for a bit. I'm sorry, but I will show some graphical information later as well. So what is user timing metrics? What is user timing API? This is, I can't call it the new API anymore. Like it's pretty old API by now. It's just, it's the way of putting some marks on the performance timeline that is part of pretty much all the browsers engines these days. So setting marks on that timeline of high quality, high resolution timestamps. And the way of getting the timing for those marks and then measure the differences between different marks in order to say, like, this event, or like this process took so long, and this process happened at exactly this point of time. Technically, the main question is why user timing API? Like, we have so many metrics, because if we take a look at the main site speed performance dashboard, like the number of metrics there is overwhelming. Like time to first byte, time to first contentful paint, like last contentful paint, all sorts of metrics. What is the problem? Why do we need even more metrics? Because they are custom metrics. Technically, there are two different types of metrics. There are generic ones and the custom ones. The generic ones try to make an educated, yet still a guess about what matters the most for your site, for your view, for your project, and then measure those things for your for your views. Sometimes it works, except for the cases when it doesn't. And in the hybrid applications, as we have at GitLab, when we have Rails application with HAML views, incorporating view applications, the things become really complex and for the generic metrics. And I have the perfect example to demonstrate that, like the example that I already showed. But now let me just start sharing my screen, and it's going to be interesting to see, I guess. So first of all, in our project, like the user timing metrics, these are custom metrics. As I said, we put the marks wherever we want, and this allows us to measure the performance of exactly the elements of the page or the applications on the page that we care about, that make the most sense for that or another view. And we have incorporated those user timing metrics, obviously enough, into two areas at the moment, snippets and web ID. And web ID is the perfect example of why generic metrics are not necessarily what we really want to measure. So if we take a look at this new shiny dashboard that team thankfully helped to restore today, that was gone right before this call. So if we take a look at this dashboard, let me just close this. These are the metrics that we try to take care of on the product-wide scale at the moment. They called Web Vitals and consist of 3 parameters: the largest contentful paint, LCP, cumulative shift. This is like the number showing how often do you move elements around. So like how well the elements take their places so that your view doesn't look like very shifted for the user. And first input delay, this is the time that your page is technically unresponsive. So user cannot type in anything or like use any inputs or something. So, and this largest contentful paint, the LCP parameter, is what we really care about. And this is part of our KPI for engineering. We have to make this parameter as low as possible for all the views. And we have some metrics and some core views that we have to care about. But when it comes to the web ID about repo, so this is the, I'll try to show to open this. This is technically the repo that we get when we just go to click web ID, and this is what we get. So master without any branch, without any merge request. This is the view that we get. According to the LCP, we get really good performance. Like 2.7 is fine. That's why it's green. It's like considering the size and the heaviness of the web ID application, I would be happy if this would be correct. And this LCP parameter is correct. This is how browsers measure and evaluate, in particular, WebID. Like technically, crawlers don't evaluate that page of WebID because you have to be logged in, and crawlers don't log in really. But would they have this opportunity? This is what would go into all the dashboards, and that's how our competitors, for example, would evaluate us. However, the problem is that using user timing API, I could set the metrics and marks to exactly measure the performance of the parts that we really care about. In this particular case, I care about how fast the navigation on the left side gets loaded, because this is one of the cornerstone moments in the life cycle of WebID, of loading the WebID, where users can say, okay, yeah, I can start using this. This is WebID. However, if we reload this page once again, you will notice that clearly the navigation tree doesn't take 2.7 seconds, right? So there has to be something wrong with the LCP parameter, and there is indeed. So because right now to load the navigation tree in the WebID takes 7.3, nearly 7.3 seconds. And this is the difference between generic metrics like LCP and the custom metrics. Custom metrics allow you to measure exactly what you want, because in this particular case, ironically enough, the LCP measures exactly what we tell it to. It measures the largest contentful paint. What is contentful paint? Is a paragraph of text, header, and image. And if we go back here, look at this central part. And this is our LCP, loading this image that makes no sense for WebID technically. This is our LCP. There are two things to keep in mind here. First, LCP does not necessarily show us the real performance. So if users complain about performance of any application in our product, we have to really be careful with relying on the LCP. But at the same time, if we really want to trick our competitors or the crawlers and give us better score, we could use this to trick them into thinking that our LCP is actually better than it is in reality. But this is like dirty technique. I don't advise that. Just like, you know, we'll talk about this after recording. Now, this is the difference between custom metrics and the generic ones. But let's talk about these custom metrics now. So Web Vitals go off the screen now. First of all, as I said, we can mark the things on the timeline and we can measure the things on the timeline. Now let's let me tell about how we do this. Let me just do this. So since I didn't prepare the slides, I will just draw while we are talking. So imagine the timeline. This is our timeline of loading our page, let's say. So using user timing, we can set different marks on this timeline. For example, this is the start of our application. And this one will be the finish of our application. We will talk about how and where we put these marks later, but we can put two marks. What does it tell us? It tells us when our application started to be to load or to be bootstrapped, or as in the case with WebID, I know when my navigation tree started to be bootstrapped, when it's finished to be bootstrapped. But then, I'm sorry. But then the difference between these two marks can be measured, and it has separate entry in this performance timeline, and this is our measure meant, but it's called measure in the API. So we do not need necessarily, when we measure the things, we do not necessarily need to specify finish or start. So if we do not specify finish, let's like this, without finish, we will be measuring from our start point all the way to the moment when we measure the things. If we omit the start mark, then we will be measuring from the very beginning of the loading process of the page on to the moment the measurement is taken. So those two parameters, the start and end, are arbitrary, optional, but it's really nice to have those to measure on a more granular scale. So on this dashboard, we show metrics. In this particular case, web ID tree loading from request. So we measure the measurement, and then we have 3 different marks on this on this page as well that are called web ID app start. This is when the view application kicks in. The view application starts bootstrapping. Web ID tree start. This is when the component with the navigation tree starts rendering or bootstrapping. And tree finish. This is when I know that the tree has been output on the screen. So these 3 marks and 1 measurement allow me to see where are the main losses of the performance. For example, we see that the difference between web app start and web tree start is minimal, but the difference between web ID tree start and web ID tree finish is really significant, about 5 seconds. So this is exactly where I'm going to look at, and if needed, I will add more marks to know what is going on there, or I will just figure out what is the main abuser of the performance for this particular component. So this is about this is a bit ahead of time. We are getting to the monitoring of the things, but let's talk about just generic user timing in the GitLab, user timing metrics in the GitLab. So do we have documentation? No, not yet. I'm going to provide some in 13.6, hopefully. But there are the merge requests that you could use as the guideline. We talked about raw API just briefly, like there are marks and there are measurements. If you want to know how it looks in the raw API, here is the file called performance utils. We will get to it a bit later. Performance mark and performance measure. These are the things, the standard things. This performance is the global object that is supported by all major browsers nowadays. You don't need any polyfill or anything like this. This is standard browser API called user timing. Sorry, this is not part of user timing API, but this is the part of the umbrella performance API in the browsers. So performance mark sets the mark, performance measure sets the measure. However, it will be, I started implementing user timing metrics using raw API calls, but over time it turned out to be a bit unpredictable and hard to maintain. So I ended up building some GitLab specific abstractions and helpers. So the first thing to note, there is the file called performance constants. It's in assets, JavaScript's performance constants, where you can see the naming conventions. So we do not use string literals for measuring performance in the components. Like we should not, because at some point there will be the linter that will fire an alarm if you are trying to do this. So all the namings for marks and measurements should go from this performance constants file. Here you have the examples for snippets and for the web ID. So you can play around with this information. So all the namings, all the string literals go in here. Then another thing, we have the performance utils file. This is the main abstraction that you should communicate with when you implement custom user timing metrics. It's really trivial thing here. So performance mark and measure function that takes mark and measurements, should you need those. So you can specify either marks or measurements, or you can specify both. and it will do the things for you. The reason we had to move it into the abstraction, because I wanted this to be done not at the moment we request these things, but I want to put the burden of requesting the next animation frame on this utility component to get as close numbers to reality as possible, because usually view components will trigger performance events. If you put it directly into the component, they will trigger them when, for example, the component gets bootstrapped or the DOM is updated, but it doesn't mean that actually it got re-rendered. So I want to measure the things after the things get re-rendered. Another alternative would be to sprinkle next tick in all of our view components, but then this would make it very hard to maintain, and moving next tick into this function would mean that this function could not be used for measuring performance of the HAML part of our application, and we still have a lot of views in HAML there as well that we want to measure performance of. This is the main sort of entry point whenever you want to measure performance in GitLab. In order to make things a bit easier, there is the example merge request where we implemented the things for WebID. So if we get to the changes here, here I changed 3 files. ID, this is the root application for the ID tree list in order to put the metrics that we just that we have seen just now, and then repo editor. This is used for WebID view with the file. So whenever you can get directly to a file, for example, if I open this editor config file, and that measurement actually goes straight to the file. So I want to measure performance of how fast does it take to start loading this file, since it is already in the URL. And technically, this is exactly what user wants to get to. So we want to make sure that that file gets rendered as soon as possible. So we want to know when the rendering of the file starts and when the rendering of the file ends. So in this merge request, I put the measurements into the repo editor component, and this is what it gives us. So it not only provides us with the tree navigation performance, but also not only the tree loading performance, but the WebID file loading performance. And here we see that the things are not as good as we would hope. But ironically, LCP in this case is actually correct, because somehow it does detect that there is something happening after that image being rendered on the screen. So it just tells, once again, that LCP might be not telling you the full story. And in this particular case, we have more marks, obviously, the set of marks related to the tree rendering and the set of marks related to the file loading. So that's why 3 files. So tree is for the navigation tree, repo editor is for the file. What's about the ID, the root application? So the idea is that in order for the whole process to be maintainable, the idea is to catch all the performance-related requests from the child components only on the root level, of your application. So try not to call this utility method performance mark and measure on the child components. Try to communicate this to the root application and then let root application manage the thing. So how is it done in WebID? Let's take a look. Here we are importing all the constants that I showed you in this naming convention file, and then we actually will listen to the events that child components emit to our event hub. Yes, I know event hub probably is not the best solution, but in this particular case, event hub of WebID is working only with performance metrics, so there is no danger of catching some long synchronous task that would postpone this process. So we route things through the through Event Hub, communicate to the top level, to the application level, and then application sends all the requests to our performance things. This has been actually changed later at one of the later merge requests to make more sense for all this process. And I will link to that updated merge request later. But the process is as this. Your child component wants to measure performance. It emits the event, root application listens to this event, and measures the things. So then we know all the marks and measurements that are happening in this part of the application. And it's really easy to maintain this thing. I'm speaking. Do we have any questions so far? I'm sorry for pushing this so. No questions? Wonderful. So let's go on. Yes, we were talking about existing examples. Snippet, web ID. This is, we took a look at the dashboard for the web ID. There is the same thing for snippets. Obviously, we're not going to dive into that. But how do we? I already told how we measure this, but there is an interesting thing how we can measure user timing metrics without actually waiting for those data to get to the dashboard, to the Grafana dashboard, right? So we are on this page. Oops, not that one. The DevTools. Let's let's do it this way. So we are on the web ID page. In this particular case, I have the performance bar enabled. We will have the performance bar performance session later, right? Probably the next one will be dedicated to the bar. But there is an interesting thing related to this bar. If you have the performance bar enabled and you reload this page now, wonderful graphics implemented by Tim tells you that you do have performance bar enabled now, and it starts spitting some information into your DevTools, into the console. Among other things, so if you ignore like Grammarly metrics, technically your extensions that you have in your browser can measure performance as well, and that will be output into your console as well. So this might be a side effect of this. Nevertheless, all of those marks that we have seen here, so web ID app start, web ID tree start, whatever. So we have all of those output into our console, and you can measure those things right here, right now, in order to understand whether, for example, so you have some big change, right? So this allows you to take the measurements on your machine before you make those changes, make the changes, run this very rough test again with your changes and see how the numbers get changed. So it will tell you whether the performance degrades or improves right here, right now, without waiting for that data to get to the Grafana dashboard. So this icon, the target icon, means the mark that you have put into your application, and then this ruler thing means the measurement. So then you can see the measurements of the of different measurements that you took during the loading of that or another page. So in this particular case, we see that, yeah, tree has been loaded within 6 seconds, and file. So this is not from the start. This is just from the start mark to the end mark, not from the beginning of the loading. If we want to know the file finished loading, oh, that's that. Yeah, file finished actually. Yeah, in this particular case, I measure from the moment the page started loading. So 7.5 seconds. So this number is not that big at the moment. I have no idea what happened here. It's from 6 a.m. today. So I don't know. At the moment, the numbers are not that bad.
Measurements in the dashboard, they are coming from site speed, or? Yeah.
Yeah. Yes. Yeah.
The site speed machine is definitely not a super strong CPU.
Right. Right.
So that's
so
all the timings are always like a little bit higher than your local machine. Simply
right. Right. And also this is cold cache measurement. So this is something to keep in mind. So these measurements in the console can tell you the story between the moments before your change and after your change. These are not reliable to say, okay, our performance is this now, because this is not. These are the numbers for your particular machine, your particular connection at this particular moment. That's it. But it gives the good understanding, or like basic understanding of whether your change dramatically changes something or not. And also, we will be talking more about this. Like you can see those Web Vitals parameters output into the console as well. But we won't touch those at the moment. They will be covered by the performance bar session, the next one. So this is how you can get to those metrics when you need those. Just don't forget to enable the performance bar. If you disable the performance bar, you won't get that output. Now, what do we have? How to constantly monitor the dashboard. I started talking about dashboard long before I had to, but you saw that. Going through monitor parameters to on the dashboard. Right. So technically, the interesting thing here is actually, we have several dashboards where we implement this runs toggle. So I don't really advise doing this on the 7-day scale, probably, but it might work as well. Since we are on Zoom, and if you enable the runs, you can just get to, you hover over this marks and you can get to the result page. And this is where you get the raw site speed output for that particular run. And that's where you can figure out, okay, why the numbers are getting so high or the numbers are getting so low, like what affected that. So you can get to the waterfall and see the things. But in order to get better understanding of how to use this tool, please refer to the very first session on performance that team held 2 weeks ago. Yeah, 2 weeks ago, where team dives into a lot of details of this. And it's really exciting to see how things are measured there. So with that, technically, that's pretty much, I was rushing like mad, I don't know why. But yes, questions. Now, team, do you want to voice?
Thanks a lot, first of all, and especially on such short notice as we moved our topic. So the numbers automatically land in site speed, so we don't need to configure anything additional. So as soon as they are implemented, they are there.
Yep. Yes. Nothing additional. They just go there. Site speed is smart enough to pick those. Again, as I said, this is the beauty of basing this on a standard web browser API. So site speed knows that API exists. Site speed takes those numbers.
Yeah. Awesome. That leads to my main question. Is there anything that we could think of that makes really sense to measure on a global perspective? So on every page automatically in reality, like how long does it take our initialization on main.js, the on DOM content loaded, or hopefully soon not anymore DOM content loaded, and also our deferred loading. So should we measure that? Would that make sense? How do you see that?
Well, I left the comment on Research Performance channel last week, I think. I suppose where we should start is we have 5 top routes for our KPI metrics, right? So I would go on and implement, like again, using the naming convention, introduce the new naming convention for the very, like the core element of a route. The element that users get to go for when they type in the URL or click the link. For example, for snippets, it's at least the rendering of the very first snippet, if we're talking about multi-file snippets, right? For WebIE, if the file is in URL, this is the file. If not, this is the tree. For project, this is the list of the files. So every route has one core element. So I would go on and go through those five most visited routes, and using naming convention, implement the mark or measurement for the main element. And those things would go into the dashboard, and then we would be able to see real performance for those views. Then we could extend this pattern to all the remaining views, routes, but that doesn't sort of push us hard. We can just take it over time and create the epic and implement that. And then on top of that, again, we could still extend this measurement by measuring some secondary elements that are not sort of crucial for rendering that or another page, but it still makes sense to measure because they either extend or like give some additional context to the user, and so on and so on. The starting point, I would say, we take the 5 routes, we implement the measurement for the core element, and that's where we go from. Then we extend. That would make sense to me.
Good. Yeah, no, I think the big question is really how much we can reduce our main base loading, so everything that we do on every route, every time, and
everything we do on the same route is just the toolbar technically. That's pretty much what we do on every load. And
we
measuring
on the main.js, we are checking a lot of times, like is this element there, this stuff. We have jQuery. We are doing also. There are 2 topics there. One topic is the main.js, where we have a better understanding by now what is actually going on. And I think we have optimized it some parts quite good already, even as we know we need to keep the jQuery stuff at least for some time, some more. But as soon as you go like a level deep, then you can see funky stuff, like, for example, on the overall JavaScript that is running on all project pages, we are basically sometimes initializing something that is just used on one sub page, but it's every time called whatever we do. And yeah, I think we have a lot of stuff that we need to.
This is perfect scenario for user timing metrics. Like, as I said, for example, let me just share my screen again. I think it falls to this example of the about repo thing. Yeah, actually, I didn't mention this, but you can select several pages here, and those will output as well. Like, this one is not available for empty one. So if the metrics, if you compare it to views and some of the metrics or measurements are not available in one of the views, it will just show no data. So don't be afraid of that. It's just that team page does provide the file loading measurement, and the empty repo obviously doesn't provide that. So that's why it gets no data, but don't get afraid of that. So the scenario you were talking about, Tim, is exactly covered by this thing. So if we take the project scenario, right? So let's say project home route, okay? So we want to know when we start rendering the files and when we finish rendering those files. And these 2 marks will tell us either we start rendering way too late, or we start rendering fine, but it takes us very long to get to the final mark. So to identify whether the problem happens before this or between the start and the end marks, then we can say, okay, then we can analyze what affects this delay between these 2 marks, for example. And then we can get deeper and deeper and, for example, say, okay, we can even mark when the very first file gets output, because not necessarily they will output all at the same time, because there are some metadata. There is some metadata being fetched for those, right? So we can, with user timing, we can get as granular as we want, and that will tell us. And we don't necessarily even need to, make those marks persistent. They are perfect for local development as well. For example, I'm going to I have the one of my deliverables for this milestone is to write the technical discovery for Web ID performance. So I will sprinkle a lot of marks locally while doing that to measure different parts, what affects what, and that will give me the information where we are losing time, what delays that event or that event. And those should not necessarily be put into the code permanently, right? I'm going to use them just for the development. And the same thing for the projects. So we know that there is a problem, for example, and we start figuring out what is going on. We work on the technical discovery on how to improve this thing. And we just sprinkle the marks, measurements, and then we get much better understanding of what is going on, because relying our judgment just on LCP doesn't really give us any data, right? So it's just a number that doesn't tell us the story. Where
you need
we are
to definitely look behind the data. I think
it might tell us that we are losing some time, but where exactly? No chance.
It is deep diving, exactly.
Yeah.
And I think the measure marks are perfect for actually finding even locally stuff. What I have seen simply is that it's sometimes quite hard. So so the user time metrics are even better, because it's the time to first byte can be very different locally. It can take 2 seconds, 4 seconds, 5 seconds, 2 seconds, 3 seconds. So really depending on how your machine or what it is doing right now, it gets better the more iterations you have. But I was looking right before that session to something, and I was running GDK measure, 4 runs, 3 of them quite the same, and 1 was just going off the charts in reality. It's like double the timing, and the user timing metrics are taking away this calculation of the especially time to first byte. It's really narrowing down. That's what I also like about them. So cool.
Also, keep in mind that I might confuse the things, but for example, if we want to technically with user timing metrics, we can script the performance, make this part of our pipelines, and output the information. I have the script locally that technically makes 5 runs on my local branch, on my local instance, and records all the user timing metrics, outputs the average for me for all the marks and metrics that I put into that or another view. And that's a good basis. I'm not sure if this is possible with the LCP without actually pulling this whole Web Vitals thing that does some magic internally. With user metrics, it's much easier. You just run the things automatically through your branch, compare it to master. We are done. Like, do we degrade? Do we improve? That's it.
Good. Any other questions? No. Good. Then thanks a lot again for the great introduction to user timing metrics. I have put a couple of other topics on the agenda that I would like to simply give a quick overview where we are at the moment. So there is one thing on the Q3 OKRs, and let me share my screen right now. So we are seeing definitely some improvement. So especially the issue list, which was above the improvement mark, is now going below it. It was also the longer weekend, but it definitely got better. Issue detail is also quite the same. The MR list saw also some improvement, so I see like a nice step. But the bigger topic still of the MR list is that we see still a lot of fluctuation. This is really due to the time to first byte. So it can happen, I think the fluctuation over 30 days, it was around 500 milliseconds, which is too much. Because this is not an even highly used project or anything that we are doing, but it seems that some component on our backend is under too much pressure, and we are already investigating that. The MR detail also is now again below the improvement mark. And I think the combination of the things that we are doing right now with the moving the DOM content loaded initialization forward, that is a nice improvement. And simply reducing the CSS is having a nice impact. And there are a couple of bigger CSS files that are currently in the pipeline that I'm really looking forward to seeing getting out of the bundle. So this should bring us shortly below 1 megabyte, uncompressed, but optimized. So that should be also nice. Another thing that we are already preparing for Q4 is that we are going to target more LCP on all routes that we have. And this is currently in the definition phase. And as you can see, we have a couple of pages that are really taking already 16.9 seconds. And we have a clear target to get it into the green area that is also recommended by Google under 2.5 seconds. So that's our first target now. It's really how many can we get below, how much improvement will we see. The bad news is that the ones that are very fast at the top over here, they are simply misconfigured at the moment, and they are all 404s and static sites that are not measured at all. So we need to clean those up at the moment, and then should have a better overview as we are closing in on Q4 start to know what we need to improve and where we need to improve more of those pages. And as you said, I think LCP is not perfect for all our use cases, but I think we have still 80% of our use cases at the moment are very roughly nicely measured by LCP. But what is measured by that? It's just the loading of that page. We need to improve. I think we are going into an evolution most probably over the next 2 quarters, which is really going from cold cache and speed index to cold cache, LCP, hot cache, LCP, and then getting more and more into, okay, at least all the pages are loading now in a fine way. And I mean, everything above 4 seconds is simply way too much. So improving that part. And as soon as we have the loading, it's really also investigating in parallel then really around the use cases, really introducing the user timing metrics, and also not only just loading and showing stuff, but also really how long does it take to submit an issue? How long does it take to select something from autocomplete? How long does it take a full workflow from creating a project, creating an issue, creating an MR, changing 2 lines, committing those 2 lines, and then they are back in so that you basically test the full workflow and the full system on that. And yeah, and the other thing is that what also is nice to see is that that's the wrong list, wrong link, CSS statistics, is that our CSS statistics are also improving at the moment. So all those super huge selectors are gone. There are still a couple of them left, as you can see here, but they look not too bad. And a couple of them are anyhow also gone quite soon with the removal of the pipelines as CSS and a couple of other things. And that has already also made a nice reduction. I think one of the bigger things that we then need to take a look at is, for example, our biggest, I brought this up as a discussion point last week, is our spacing and the old spacing utilities from Bootstrap, not the new spacing utility classes. So that is currently the top file that has the biggest creation of stuff at the moment on the rules side, and select 2, and that is also something that is currently in the process of getting out of the main application CSS, and that should show us some more nice improvements, I believe. Any questions on those? I need to move on my. So latest improvements as updates. Avatar resizing is live on .com, a very long topic, but we have on production avatar resizing. What we need to investigate, especially on the front-end side, is to take a look at the different sizes that we are requesting, as we have some components that automatically simply take the width and the height and just request it directly through the URL parameters. So that is something we need to figure out to reduce them really to, I think 6, 8 are defined as the actual avatar sizes, and we need to get those down in numbers. Another thing that is in the making right now, as mentioned, is lazy loading of CSS components. So we have now a way that we are able to load at the later point the CSS of not a page, but something specific. So for example, we have a couple of vendor CSS in our application CSS, which is Cropper, At2, and the biggest one is Select2. So Cropper CSS is mainly the testing point to get one CSS file out of application CSS, and that we have then a nice way to actually say, okay, load this lazy bundle of CSS at the later point so that we can reduce it. Because, for example, Select2, as we saw in the statistics, is quite huge, also in numbers, and should give us also nice improvements. As soon as we have those vendor stuff out, I think it's 4 different libraries at the moment, we then can also take a look if in the future we might take also the CSS for charts out or anything that is like a bigger thing and just load it also as any Webpack bundle at a later point. But we have a workflow for that now, and that should also make it much easier. And one thing, what I've just mentioned that would be, is I'm trying to figure out if we can identify in an easy way if site speed is testing that page or not, or if we need a cookie for it. I took a look at the navigation user agent string. It doesn't add anything, Lighthouse does. Now the question is why? Because what we are doing, and this is not a long story, is for the emojis. No, it's not avatars. I love to mix those up. It's not avatars, it's emojis. So for emojis, different OSs have different emoji fonts, which have different emojis which are supported. So Windows is the best example. It doesn't support any flag emojis natively. So what we need to know is what type of emojis do you support, so that every emoji that you don't support, we basically create a fallback. How is this happening? This is a very hidden area in the GitLab source code base. This is an old school trick that was implemented also ages ago, is that the first time you are landing on any page on GitLab, which is using an emoji component, we basically draw to a canvas emojis, all emojis that we know about, and take a look if those were rendered as boxes or nothing, or if they were rendered as actual emojis. And based on that, we know, okay, your font is supporting it or your font is not supporting it, which is definitely a high CPU task and is not something we should measure in our normal workflow. Because right now, every time you hit an issue list, you hit an issue, you hit an MR, site speed is going out and is drawing this map to a canvas and is trying to figure out if their machine is supporting it. So this is not even cold cache, I would say. So the idea is to simply have a check, okay, you are a headless browser, you are Lighthouse or site speed, and then we basically say, okay, this emoji Unicode is supported. If you draw now a black box or not, we don't care. But that we are not doing a check on top of that.
But wouldn't it affect the measurements really? Because if we access the same route with the real browser, we will still draw everything to the canvas, and this will take time. But for site speed, it won't be the issue. So site speed won't tell you that, yeah, okay, you spent so much time for drawing this thing.
Yes, but that's the question: is this something that we should measure? Because this is really just happening on the first URL visit. This is like the classic website versus web application. And as we want to move over to a hot cache in one of the next steps, this would be also something that we would need to cover so that we get more realistic measurements, because we want to measure what the user is actually seeing on their normal visit, rather than an arbitrary load something from a clean slate, which is, I think, the strategy that we are moving into. With starting of next quarter, we most probably will switch to a hot cache, but it's a hard question. So the idea is simply to figure out, do we know if it's site speed or not? And then we can also update on that part. But I believe that some of our CPU is simply lost there. So the other thing is that we do this beforehand, which is also something we could research, is can we include this into our JSON? Because the mapping that we know of is much smaller by now, because the mapping in past times, which emojis were supported and which not, was much larger. So this might be something that we is also investigate, so that perhaps we just draw this then canvas check for 10 different icons that anyhow everyone knows. I don't know. I'm not too much into the emoji Unicode world. So
that emoji drawing thing that we're doing, we also, I don't know if you remember seeing, someone was complaining on Twitter because Firefox right now in an experimental mode, but possibly in the future, actually throws a security error on drawing it, and tells people that it thinks that we're tracking them because we're drawing, because that's the way that people often track people, is by drawing an ID to the canvas and then reading it off. So there was a tweet a while ago now, a couple of months, where yeah, somebody had enabled the Firefox experimental security and privacy settings, and that was causing us to throw. So it's also a reason to sort of maybe reconsider how we're doing it.
Very good point. So if anyone has an idea, bring it up, please, or I will bring this topic also to tomorrow's front-end meeting, or if I can't join, at least set it on the agenda. So if someone has already experience with it, and I think, yeah, the tracking point is even something that we should, yeah, look into this faster than later, because then we have the performance improvement and we are also getting rid of funky things. And it's not about funky things, so it's really just figuring out what emojis are supported. So that shouldn't be too hard to know beforehand. Thanks for that input, Sarah. Good. Perfectly landed in time. Not too bad. Thanks a lot again for coming today. I wish everyone a great rest of your week, and see you soon in another meeting. And I will put this as soon as possible on Unfiltered, so that everyone who was today on their PTO can watch it tomorrow. Take care, and thanks again, Dennis.